Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on independent events. So two events are said to be independent if they don't affect the chances of each other. So for example, getting heads on a coin and rolling a 4 on a die are independent because they don't affect each other. If I toss a coin and roll a die at the same time, they don't affect each other. It doesn't matter what happens on the coin, it doesn't affect what I will get on the die, and vice versa. So for example, doing homework and getting an A in maths are not independent, they are dependent. Getting an A in maths is dependent on you doing homework. The reason they're not independent is one affects the other. The amount of homework you do influences the chances of you getting an A. Now, that is not to say that if you do homework, you will definitely get an A. The reason they're not independent, the reason these two events, doing homework and getting an A, are dependent is because this affects the chances of this. Doing homework just makes it more likely that you will get an A. So if two events are independent, then the probability of A and B, so remember this symbol here means and, the probability of A and B is probability A times probability of B. In other words, if two events are independent, the probability they both happen is just the product of their respective probabilities. So let's say I roll a die and toss a coin. So remember, as I said before, these two events would be independent. Getting heads is independent, has no bearing on the chances of getting a 4. So if I want to find the probability that I get heads and a 4, I just take the probability that I get heads on the coin. The probability I roll a 4 on the die is 1 over 6, and I just multiply these together. So I get 1 over 12. So we've already done questions like this. Remember, we did them using a tree diagram or a table. So for this question, tossing heads and rolling a 4, I could draw up a tree diagram or table to list all possible outcomes, but doing it this way is so much quicker. Just find probability of heads, probability of rolling a 4, and multiply them together, and then I'm done. So if I toss a coin 4 times, what is the probability that I toss heads 4 times in a row? So again, previously we could use a tree diagram to list all the possible outcomes. It turns out that there would be 16 possible outcomes on a tree diagram, and that would take forever. There's a quicker way to do that. So there are 4 events here. Each time I toss a coin is a new event. Each of these events is independent. What happens on this toss of the coin doesn't affect what happens the next time I toss a coin. So if you get heads on the first toss of the coin, that does not affect your chances of getting heads on the second toss of the coin. Each time you toss the coin, you have half probability of getting heads, half probability of getting tails. So what I'm really looking for here, I'm looking for the probability I get heads, and then another heads on the second go, and then heads on the third go, and then another heads on the fourth go. As I said, each of these events is independent. What you get on the first toss of the coin doesn't affect what you get on the second or third or fourth. So, because they're independent, this probability... So I just find the probability I get heads on the first go is a half. Probability I get heads on the second go is a half. The probability I get heads on the third go is a half. And the probability I get heads on the fourth go is a half. Because they're independent, because of what I said on the previous slide, the probability that they all happen, I just multiply their respective probabilities. So the probability you get heads 4 times in a row is 1 over 16. And there we're done. How easy is that? So much easier than drawing a tree diagram. All right, now we're just going to look at a question that's a little harder. So let's try this question here. 2 dice are rolled. What's the probability that only one of the dice comes up with a 1? So remember our general rule, A and B, you times to find their probabilities. A or B, you add to find their probabilities. So this is independent events and this is mutually exclusive events. So when I'm asked the probability that only one die comes up with a 1, so I can get that 1 of two ways. I can get a 1 on the first go and then get something else on the second go, or I can get a 1 on the second go, but not the first go. So that's what this says here. So this is probability I get a 1 the first go, but not on the second go. And this is the probability I get a 1 on the second, but not the first go. So I can add the probabilities of these two events because they're mutually exclusive. I can't get a 1 on the first go and also not get a 1 on the first go. That doesn't make any sense. They can't both happen. So what I'm going to do is find this probability, and add them together. So what would be the probability of this, that I get a 1 and then not a 1? Well, these events are independent. If you roll 2 dice, the outcomes are independent. What you get on the first roll of the dice does not affect what you get on the second roll of the dice. So what we have here, for the probability I get a 1, then not a 1, this is the probability I get a 1 on the first go. This is the probability I do not get a 1 on the second go. The probability they both happen, I just multiply the respective probabilities. So now let's find this probability. Well, that's actually going to be the same idea. The probability I don't get a 1 the first go, the probability I do get a 1 the second go, the probability of both of these events happening, I just multiply their respective probabilities. So this is the probability I get a 1 on the first go. This is the probability I get a 1 on the second go. So I just add together these probabilities. So I end up, if I put this on my calculator, getting 5 over 18. That's the probability I get a 1 on only one of the dice. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.